Hey there, and welcome. Today, we are diving into a technology that is literally rewriting the rulebook for how entire industries clean, maintain, and operate. It's powerful, it's precise, and yeah, it's surprisingly cold. So just think about this for a second. You've got a really complex piece of machinery, right? It's caked in all this grease and grime. How in the world do you get it perfectly clean without scratching up those delicate surfaces, or even worse, leaving behind some residue that could cause huge problems down the line? Or, let's scale that idea way up. Picture a massive food processing plant. You need every single surface to be totally sterile, but you really want to avoid using any of those nasty chemicals that could potentially contaminate the product. It's a huge headache for these industries.
Well, the solution to these problems isn't what you'd expect. We're not talking about sand or water or harsh solvents. We're talking about turning a gas into a solid and then firing it at unbelievable speeds.
To really get why this new method is such a game changer, we first need to take a quick look at the major downsides of the tools that industries have been stuck with for decades. So, your classic methods, they all come with some serious baggage. Take sandblasting. It's super aggressive. It can actually damage surfaces and leaves all this grit everywhere that you then have to clean up. Pressure washing seems better, but it can cause rust, and honestly, it's pretty much useless against heavy oil and grease. And then you've got chemical cleaning, which means you're dealing with hazardous materials and all the environmental risks that come with them.
You see the problem, right? Each of these methods kind of solves one problem while creating a whole new one, whether it's damage or waste or just major safety hazards. So what if there was a way to get that powerful clean without any of those downsides?
Well, the answer to our cleaning dilemma is surprisingly elegant, and it all comes down to something frozen. We are talking about a technology that cleans with solid carbon dioxide.
It's called dry ice blasting. The core idea is actually pretty simple. You take these little pellets of solid carbon dioxide, yep, that's dry ice, and you use a blast of compressed air to shoot them at a surface. But the real magic is what happens on impact. The dry ice doesn't melt, it sublimates. That means it turns instantly from a solid straight into a gas. It literally vanishes.
Now, here's where it gets really cool. This isn't just about hitting dirt with something cold. The cleaning process is actually this amazing combination of 3 different physical forces, all happening in a split second.
Okay, so it's a 1, 2, 3 punch. First, you've got the kinetic energy. The sheer force of the pellet hitting the grime cracks it loose. At the exact same time, you get a thermal shock from the extreme cold. We're talking negative 109 degrees Fahrenheit here, which makes the contaminant brittle. But the real knockout punch is that sublimation. As that tiny pellet turns to gas, it expands over 800 times in volume, creating this micro shock wave that just blasts the contaminant right off the surface.
So when you combine those 3 forces, you get some pretty incredible advantages that just blow the old methods right out of the water.
Okay, benefit number 1, and this is the big one. Absolutely zero secondary waste. Because the dry ice pellets just disappear into thin air, the only thing left to clean up is the grime you wanted to get rid of in the first place. Just think about what that means for cleanup. With sandblasting, you have a huge pile of sand mixed with whatever you blasted off. With pressure washing, you're dealing with pools of contaminated water. With dry ice blasting, you just sweep up the original grime. That's it. This can slash cleanup time and disposal costs like you wouldn't believe.
But the benefits don't stop there. Not by a long shot. It's completely non-abrasive, so you can clean super sensitive equipment without damaging it. It's a totally dry process, which makes it safe to use on electronics. It's also way more environmentally friendly because it uses recycled CO2. And it's even approved by the FDA and USDA, so it's safe for food-grade environments.
So what does all this look like in the real world? Let's talk numbers. There was one case study where a major food processor was able to cut its cleaning time by a staggering 70%.
And that efficiency isn't just about saving a few hours. By getting their production lines back up and running that much faster, that company saved $30,000 a month, per month. That is a massive return on investment.
So this isn't some niche, futuristic idea. Dry ice blasting is already out there, being used across a huge range of major industries to solve some of their absolute toughest maintenance challenges.
Take the auto industry. It's being used to strip all that heavy grease and oil from engine blocks and parts without doing any harm to the metal or the delicate components underneath.
Then you've got aerospace, where precision is literally life or death. It can clean critical parts like turbine blades safely and effectively, which helps ensure peak performance and safety.
And back in the food and beverage world, it is perfect for sterilizing things like mixers and conveyor belts. You get this incredibly deep clean with absolutely zero risk of chemical residues making it into the food.
And check this one out. This one might surprise you. Data centers. Because it's a completely dry and non-conductive process, you can actually use it to clean energized circuit boards and servers while they are running, without causing any electrical shorts or needing to shut the whole operation down. How cool is that?
So when you add it all up, the incredible efficiency, the safety, the fact that there's no waste, and its unbelievable versatility, it becomes really clear that this is way more than just a better way to clean. It's a fundamental shift in how industries think about maintenance.
It really makes you wonder, doesn't it? By applying some clever physics to a really common problem, we've created a solution that's faster, safer, and cleaner in every sense of the word. And if we can totally rethink something as basic as cleaning, what other fundamental processes are just out there waiting for their own revolution?